Now we did multiplying, we did dividing, now we're doing add and subtract. 7.1. Add, subtract. We don't do anything else in chapter 6. The rest you'll learn in intermediate algebra.
Was 7.1 on the PowerPoints?
Yeah, I typed it up yesterday.
Oh, yesterday?
Yeah, I posted it around 8 o'clock last night.
Okay.
So 7.1. Two basic rules you kind of need to know for these. I don't know on it. I guess we'll call them steps. Step 1 must have a common denominator, which all of them will. Must have a common denominator. In this class, they will always have a common denominator, but I want you to know when you get to intermediate, then they won't have common denominators and you've got to manipulate it. So I just want you to know you have to have that. I don't know if I'm going to spell this word right, but I always spell it this way. Squish the fractions together. Squish them together. Keep denominator the same. Keep denominator. And then step 3, simplify if you can. Simplify if you can. Most of the time, you're only doing step 2, because step 1 I told you is always going to be done, and you don't always have to simplify. So usually it's just step 2.
So you have to have a common denominator.
That you'll have. I haven't done a problem, so let me just write down your rules.
Okay, and then you'll tell us how to squish.
Yes.
Yeah,
I haven't said anything yet.
let's squish.
You're going to switch.
Awesome.
First, we're just, like all the other days, first I'm just going to start with plain old numbers. 2/3 plus 5/3. Now, I'm going to do an extra step so you can see what it looks like when I start throwing letters in there. I have the common denominator, so I'm going to keep my denominator. That was the second rule. Keep the denominator. And when I say squish the fractions, you take the first fraction, numerator, plus the second fraction, numerator. So I'm just squishing the two tops together. Again, this step you don't have to do with the numbers. It's very simple to just add them. And then once you do that, you simplify. So on top, 2 plus 5 would give you 7, and you keep it over 3. Do these numbers have anything in common? And that's as far as you can go.
Well, they're both fine.
You gonna turn it into a decimal?
Don't have to turn it into a decimal, don't have to turn it into a mixed number unless you really want to.
Oh.
Again, that middle part, you don't have to do. I'm just showing you what it's going to look like when we get to the letters. That's what I mean by squish. You're putting the tops together. Let's say we have a subtraction one, so I have one of each. 6/7 minus 5/7. Again, you have to check. Your denominators are the same, so keep it over your denominator. You're going to squish your tops together, so 6 minus 5. And then when you reduce that, you're going to get 1 over 7. So that's what it looks like with the numbers.
Are you going to be throwing some negatives in there?
What do you mean negative?
Where it'll be like -5 over 7.
It could be, yeah. It's
Okay.
just integers, though. All right, let's look at with the letters. 4x over 3 plus 7x over 3. This time you have a letter involved. Again, my denominators are the same. I'm going to leave it over 3. If you need to do this intermediate step here where you actually write the squish part, 4x plus 7x, just to show that they're together on the top, What would the top simplify to?
11.
11x over 3.
Yeah, this may be a dumb question, but why wouldn't we square the x?
You only do that when you multiply.
Oh,
Because you're saying I have 4 cookies and 7 cookies, 7 cookies, you add all together.
Okay.
If you say x squared, then it's turned into like donuts.
Oh.
They don't want you to-
No, we don't do donuts.
I want donut.
Mm-mm.
All right,
No thanks.
let's try x over t plus z over t. X over t plus z over t. Well, keep your denominator, so it's all over t. Squish your tops together, so it's going to be x plus z. Can you combine those two letters?
No.
Not as far as you can go.
Oh.
You can't do anything.
I mean, you can, but.
What would you do?
Over T.
Can't go any further. You cannot combine an x and a z. Do not say it's xz. That's not what it is. It's x plus z. They represent two different numbers. We don't know what they are. Get another one. 9 over t minus 8 minus 7 over t minus 8. Try that one. What would you get when you combine the tops? 2. And you're going to leave it over t minus 8. You cannot reduce the 2 and the 8, because remember, the 8 is married to that t. You cannot cheat and go up there. So that is as far as you can get. We like this section so far? It's fun.
Can you leave it like this? Don't go any further?
It's pretty much like this.
That would be number 6.
It's a setup.
Oh. There we go. Number 6. 3x plus 2 over 5 plus 4x minus 7 over 5. Again, if you need to do that step where you squish it all together, make sure you keep it over 5. And if I squish, I'm going to have 3x plus 2 plus 4x minus 7. This is just kind of keeping it all under the same denominator. And if I combine like terms on the top, how many x's am I going to have? 7.
X minus 5.
So I added my x's, 3x and 4x. And then, LaShawn, what you were talking about with negatives, 2 minus 7. What would that do you all? Negative 5 or minus 5. Again, it's still all over
5.
5.
Can you skip that middle step?
Yep, I just said that.
Oh,
Say it
sorry.
Every time, you can skip the middle step.
You said anything complicated on
Just one more level.
this?
One more level.
Are you going to change the denominator?
No, the denominator will always be the same. In intermediate, you'll see when it's different.
Okay.
All right, turn the page.